Thank you everyone. Today I discuss about refraction through the glass slab. Before going through that, you have to first know what is rectangular glass slab. Glass slab is a cuboid in shape, the opposite face of which are parallel to each other. It is the schematic diagram of a rectangular glass slab, and these two are the opposite faces of the glass slab and they are parallel. Also these two are the opposite faces are parallel to each other. Now when the light ray travels through that glass slab, then the light refracts two times. First one, when light enters to the glass slab, that means here the light enters from air to glass. Secondly, when light emerges from the slab, that means when the light exits from glass to air. In these two cases, the light refracts. Now, here, when the light enters to the glass slab, then it refracts from air to glass. It reflects from air to glass. Air, it is the which medium? It is the rarer medium. Glass, it is the denser medium. That means light refract from rarer medium to glass. That means denser medium. And that is why light bends towards the normal. It is the incident ray and it is the original path, so it bends towards the normal. It is the angle of incident I and it is the angle of refraction R. Now in the second case, what will be in second case? Here the light exists, that means emerges from glass to air. Here this light ray acts as a incident ray. Here the light travels from glass to air, that means denser medium to rarer medium. Here the light refracts from glass denser medium to the rarer medium and refracted and bends away from the normal, because it is the incident, it is the actual path and it goes away from the normal. This is the known as the emergent ray. Here this angle is the angle of incident and this angle is the angle of refraction. But overall, this is the incident ray, this is the refracted ray, this is the emergent ray. Already we know that the opposite faces of the rectangular glass slab are parallel to each other. So this and these are parallel to each other. And they are normal, this and this. Also, they are also parallel to each other. As these two are parallel, and if you take, this is a transverse, from simple geometry, you can say this angle and this angle. These two are equal for alternate angles. Now, go to the next part here. The light ray that strikes the glass slab is known as incident ray. Obviously, OAP here, it is the incident ray. The light ray that goes through the glass slab is known as refracted ray. This is the refracted ray. That is PQ is the refracted ray. And the light ray that emerges from the glass slab is known as emergent ray. That means QB is the emergent ray. Here this is the angle of incident. This is the angle of refraction and this angle of reflection here also equal, and it is taken as an angle of incident and it is the angle of emergent. Now at the point P, when the refraction takes place first time, then you can write down refractive index of glass with respect to air, because light refracted from air to glass. So refractive index of glass with respect to air, that is equal to sin I by sin R, sin I by sin R. Now here the angle of at the point of Q, here the reflection takes place, then what will be, here the light is refracted from glass to air. That means refractive index of air with respect to glass, it will be sin r dot by sin E, sin r dot by sin E. But simple geometry says that this r dot is equal to r. That means sin r in place of write r, sin r by sin E. This is the refractive index of air in respect to glass. Now we know that mu Ga into mu Ag is equal to 1 for the reversibility of light. These two, when you multiply these two, then it is 1. Now put the value of mu Ga, it is the sin I by sin R, into mu Ag, it is the sin R by sin E. Now sin R and sin R both will be cancelled, and then sin I by sin E is equal to 1. That means sin I equal to sin E. From the both sides, when you remove sin, then it is the I equal to E. That means angle of incident and angle of emergent are equal. This implies that, what it is implies? It implies that emergent ray is parallel to the incident ray. That is the path of the incident ray, and it is the emergent ray. They remains parallel to each other. That means here no deviation, that means no angular deviation takes place for the light. But the light ray gets displaced because it has the original path, but it emerges from the glass slab in that way, so it is displaced, and it is known as the lateral displacement of light. So what will be the definition of the lateral displacement of light? Lateral displacement is the perpendicular distance between emergent ray and the incident ray. That means there is a perpendicular distance between these two paths. That the perpendicular distance between the path of the emergent ray and the direction of incident ray is the measurement of the lateral displacement. Now this lateral displacement depends on 4 factors. What are those factors? First one is the lateral displacement depends on thickness of the glass slab. This is the thickness of the glass slab. Number 2, angle of incident. It depends on the angle of incident. Number 3, angle of refractive index of the material of the glass. This is the glass slab. What material is used for this? That means what is the refractive index of the glass slab. Number 4, it is very, very important. It is the color of light. On these 4 factors, the lateral displacement or D depends on. But how? The lateral displacement increases with the increase of thickness of the glass slab. That means if the glass slab is more thick, then the lateral displacement will be more. Then the angle of incident. If the angle of incident increases, also the lateral displacement increases. Number 3 is the refractive index. If the refractive index of the material of the glass increases, also the thickness, that means the not thickness, it is the lateral displacement increases. The displacement increases, that means lateral displacement increases with the increase of all of them, the thickness of the block, angle of incident, and the refractive index of the block. Now the question is how the lateral displacement depends on the color of light. Lateral displacement is more for the violet light than for red light. That means lateral displacement is more for violet light, least for red light. Thank you.